Next problem, the second problem on four-wheeler gyroscopic effect. So a rear engine automobile is traveling along a track of 100-meter mean radius. Each of the four road wheels has a moment of inertia of 2.5 kg meter square. So here each wheel value is given. Therefore, when you are calculating net gyroscopic couple wheel due to the wheel rotation, you have to put 4 I omega omega p. So last problem, one pair of wheel was given. That's why you have put 2. Normally the formula is 4 times. Okay, please remember that. So each wheel moment of inertia is 2.5 kilogram meter square and an effective diameter of 0.6. So radius is 0.3. Rotating part of the engine has a moment of inertia of 1.2 kilogram meter square. Engine axis is parallel to the rear axle and the crankshaft rotates in the same sense as the road wheels. Okay, therefore you will have a plus sign when you are finding net couple. The ratio of engine speed to the back wheel speed is 3:1. So gear ratio is 3. The automobile has a mass of 1600 kg and has its center of gravity 0.5 meter above. So this is your mass, this is your height of the center of gravity h above the road level. The width of the track of the vehicle is 1.5 meter. This is your x. Determine the limiting speed of the vehicle around the curve for all four wheels to maintain contact with the road surface. Assume that the road surface is not cambered and center of gravity of the automobile lies centrally with respect to the four wheels. Okay, so all data are given to you. Now we are going to do this a little bit of different problem. Speed of the vehicle is not given. They are asking you to find out the limiting speed, beyond which if I go and turn, your vehicle will roll over. Okay, so given data, so radius of the path in which you are traveling is 100 meter. So the first line, a car traveling along a track of 100 meter mean radius. Okay, that is the first line. Mean radius of the path in which your car is taking the curve, the path radius is 100. Okay, your car is moving like this. Okay, so wheel moment of inertia for each wheel is 2.5 kilogram meter square. Diameter of the wheel is 0.6, therefore radius is 0.3. Engine moment of inertia is 1.2. Gear ratio is 3 times. Mass of the vehicle is 1600. Height at which center of gravity is located above the road is 0.5. Width of the vehicle is 1.5. Clear? Let's move into the problem. Weight of the vehicle equally distributed between all the four wheels. Okay, so reaction due to the weight W by 4. So 1600 into gravity by 4, it comes around 3924 Newton acting upwards. Reaction due to weight. Okay, 3924 Newton. Let V be the limiting speed. I don't know the speed. I am going to find out beyond what speed if I take the curve, my vehicle will roll over. So that speed I am going to call as V. I don't know this value. Okay, angular velocity of the wheel, omega wheel equal to this velocity of the car by radius of the wheel, linear velocity of the car by radius of the wheel. So that velocity is unknown, keep it as V itself divided by radius of the wheel is 0.3. So that is equal to omega of the wheel equal to 3.33 V. You maintain that V same unknown there, radians per second, keep it as it is. Angular velocity of precision, V by 100, correct? 100 meters is the radius of my path, V by capital R. So V by 100, that is 0.01 V radians per second. Keep it as it is. The V unknown, maintain as it is. So gyroscopic couple due to the four wheels, 4 times of I omega omega p, correct? So 4 times of omega of each wheel, I mean moment of inertia of each wheel is 2.5 kilogram meter square. Omega of wheel is V by 0.3. Omega of precision is V by 100. If you know this, you can put the answer here directly. Otherwise, keep the V as it is. Now you solve this. So you will get 0.33 V square Newton meter as the couple due to gyroscopic. Okay, of all the four wheels put together. Right? Now you will go to calculate the centrifugal couple. Engine gyroscopic effect. Okay, gyroscopic couple due to the rotating parts of the engine. Here engine is going around in the same direction as the wheel. Okay, so I omega omega p. So the speed is unknown to me. Engine speed is not given, but I know the gear ratio is 3 times engine. My wheel is engine is running at 3 times higher speed than the wheel speed. So 3 into wheel speed. Okay, so moment of inertia of engine is 1 point. There is only one engine, therefore you don't have 2, 3 or 4 in the front. So engine is 1.2 kilogram meter square moment of inertia. Gear ratio is 3. Wheel speed 3 times of wheel speed 3.33 V. This is 0.01 V. Omega precision is same for wheel and the engine because that is the speed at which you are turning. Common to both. Okay. So this engine couple comes around 0.12 V square. Total gyroscopic couple, here engine rotation and wheel rotation are in the same direction, so you add it. So 0.33 plus 0.12, so that is 0.45 V square Newton meter is the gyroscopic couple effect, net gyroscopic couple effect. Now we go and find out the centrifugal couple effect. Due to this gyroscopic couple, the vertical reaction on the rails will be produced. The reaction will be vertically upwards on the outer wheel. So actually this is not rail, this should be road. Okay, this wrongly printed in the book, it should be road, because it is just a car traveling on a road. If it is a trolley or a train or a locomotive, it is rails will be produced. As usual, positive symbol means what? Outer wheel will be upwards, the reaction will be vertically upwards on the outer wheel. This is what we have seen. Default case as per the derivation. Okay, vertically downwards on the inner wheel. Let the magnitude of this reaction on each outer wheel or inner wheel be P by 2 Newton. Okay, so that is equal to net gyroscopic C by 2x numerically. Okay, C by 2x, P by 2 equal to C, because C equal to P into x. So P equal to C by x, P by 2 equal to C by 2x. Okay, so put all the values. Gyroscopic couple value is 0.45 V square. Just now in the previous slide we have found this out. Divided by 2, this 1.5 should be in the denominator. Okay, it's a printing mistake. Divided by 2 into 1.5. So it's 0.15. So divided 0.45 by 3 is 0.15. 0.15 V square Newton is the load on, the reaction force on each wheel due to gyroscopic couple. Clear? Now we will go for centrifugal couple. Centrifugal force mv square by r. So v square, keep it as v square itself. I don't know that value. So 1600 v square by 100. It is 16 v square. Overturning couple. So fc into h. Okay. So h is 0.5 meter. Center of gravity is located at a height of 0.5 meter. So that comes around 8 v square Newton meter. CO. This CO equal to q by 2 x. C by c q. Reaction force on each wheel. This overturning couple is balanced by vertical reactions, which are vertically upwards on the outer wheel. By default, for a positive problem, it will be always vertically upwards for outer wheel and vertically downwards for the inner wheel. Reaction forces, because actually the outer wheel will try to lift up, press down. Inner wheel will try to lift up in a curve, as you have seen that GIF image of a car taking a curve. The centrifugal force will try to throw the car outwards. So outer wheel will be pressed down, inner wheel will be pressed up. Opposite of that is your reaction. So outer wheel reaction force will be upwards, inner wheel reaction force will be downwards. So this centrifugal force, let the magnitude of this reaction on outer wheel, each outer wheel or inner wheel equal to q by 2. So q overturning couple equal to q is a centrifugal reaction, total reaction, okay, into x. So therefore q equal to c by x, q by 2 equal to y by 2. We are going for each wheel, each pair of wheel is q. So for each wheel is c naught by 2x. Okay, so q by 2 equal to c naught by 2x, 8 v square by 2. This 1.5 should be in the denominator. This is wrong. Okay, please correct it. So 8 by 3 v square. So 2.67 v square m. Okay. So we know that total vertical reaction on each outer wheel, all plus symbols, w by 4, p by 2, q by 2. On each inner wheel, w by 4, p by 2, q by 2. So in the last part of the derivation, we have seen if the sum of these two is greater than this, your vehicle will topple. I have told that in the derivation. Okay. Now this is the condition I am going to use to find out the limiting speed. Correct? Do you understand? This logical. If p by 2 plus q by 2 is greater than w by 4, then your vehicle will roll. So that using that I am going to find out the limiting speed. I am going to ignore the outer wheel. I am going to take the inner wheel condition. So because it is logical to find the limiting speed. So I am going to take the second equation. So I have just rewritten it. I have taken the minus symbol outside and I have put plus here. Okay, that's what I have written here. We are using this to find out the limiting condition. Okay, so from equation 1 we see that contact between outer wheel of the road surface is always vertically upwards. In order to have contact between inner wheel and the road surface, the reaction should always be vertically also be vertically upwards, which is only possible if P by 2 plus Q by 2 is less than or equal to W by 4. If it's greater than the weight of the car, your car will roll. So using that, we will find the limiting speed. Okay. So use the same, exactly same, P by 2, Q by 2, W by 4. All the four values are known to you. You have just now found out. P by 2 is 0.15 V square. Q by 2 is 2.67 V square. W by 4, numerically I know the answer itself, 3924. Okay, mg by 4, 1500 kilogram into 9.81 by 4 is 3924 Newton. Okay, using this, now you take it as equal to and find out the value of V. That's all. That is your limiting speed. Okay, 2.82 V square equal to 3924. So V square is 1391.5. So take square root, 37.3 meter per second. If you take square root of this, you will get 37.3. So velocity should be less than or equal to 37.3 meter per second, which is, we convert that to kilometer per hour. So which is 134.28 kilometer per hour. So in a 100 meter radius circular track, if you travel in this given particular car at a speed greater than 134.28 kilometers per hour, your car will roll due to centrifugal force. And the net result of gyroscopic, centrifugal, weight, etc. everything. Okay. So that completes the problem. You have found out the limiting speed. Limiting speed of the vehicle around the car, around the curve, for all the four wheels to maintain contact with the road is 134.28 kilometers per hour. If you travel at 140 in this curve, your car will roll. Okay. So as long as you are traveling in a straight line, you can go at any speed. Suddenly you are getting a curve. Your car will roll if you don't slow down. Your car will roll to the side as shown in the cinemas. Okay, that completes the problem. This problem is taken from a Kurmi textbook, example 14.1.